Okay. A unit vector is a vector in the same direction as the original vector, but with a magnitude of 1. So, for instance, if you have some vector that's going down here in this direction. So here's a vector going down here, and it has some certain magnitude, say like 10 or 15 or 72.37 or something like that. A unit vector is another vector that would lie right on top of that vector, except its length, its magnitude, or the length of the picture of the vector, the magnitude of, we'll call this vector v, would be equal to 1. Okay? And that becomes important when you're dealing with dot products and you're trying to solve vector problems and things like that, because a lot of times it's nice to have a unit vector. And the formula for a unit vector, if we call it u, okay, it's just equal to the original vector. So if there you have, it's just the original vector divided by the original vector's magnitude. Okay, just like that, because if I divide a vector by the length or the magnitude of the vector, what am I going to get? I'm just going to get 1. Or another way to write that is 1 over the magnitude of the vector times the vector, where v is a vector and v with the double bars is the magnitude of the vector. Okay? So, for example, for v equals negative 1/4 find the unit vector magnitude is 1. Okay? So all you have to do for that is take the vector negative 1/4, negative 1, whoops, where's my 1? Negative 1 comma 4, and divide that vector by the magnitude, which in this case is going to be the square root of negative 1 squared plus 4 squared. And if I simplify that a little bit, you could write that like this as negative 1, what does that make? Square root of 17? Square root of 17? Because negative 1 squared is plus 1 by negative 1 over the square root of 17, comma 4 over the square root of 17. And you might ask, do you want us to rationalize that? Not in this case. Okay, not yet. You know what I mean by rationalize, right? Bring the square root up top and all that good stuff. So to verify that its magnitude is 1, I want to take this thing and take the square root of the square of those things. Okay, so if I did that, I would just take the square root of, so the magnitude of b with double bars on it is going to be equal to negative 1 over the square root of 17 squared plus 4 over the square root of 17 squared. And if I do that, I get the square root. When I square a square root, what happens to it? What happens to that square root? 17. That's why I didn't want you to rationalize, because it would have up. What's 4 squared? You know, 16 over 17, which is equal to the square root of 17 over 17, which is equal to 1. So we just verified that its magnitude is 1. You get that? Better. So in other words, if I had some vector that goes from 0, 0 to negative 1, 4, right? So here's this vector going up like this, okay? So that vector has a magnitude of the square root of 17. This vector right here, negative 1 over the square root of 17, blah, 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 would be a vector lying on top of that vector. It would be a vector on top of that vector, except it would only, oh, why is it going backwards? But it would only have a length of 1. Let me try again. I don't know, it's hard to see. But I don't know why the arrow's down there. Okay. Questions? Easy? Okay. What's next? So now we gotta learn the harder stuff. Directioning, where am I? Subtraction vectors, unit vectors, talked about that. Talked about that. Okay. So these two vectors, whoops, we like this paper better. So 1, 0 and 0, 1, those are called the standard unit vectors. And they're equal to certain things, okay? This one is equal to I, not imaginary number I, just the number, just the letter I. And usually they write that in your book in boldface, okay? And this is equal to the letter J, okay? So any vector, another way to write a vector is in, this is not called component form. It's called linear component form. So any vector, if v equals v1, v2, okay, I could write that as v1 in the I direction plus v2 in the j direction. And this is called a linear combination form. Linear combination form of a vector. So it's just another way to talk about vectors. And when you do dot products and when you do cross products, which I'm not sure if we do cross product in here, but you will either next year or we did cross product in pre-calc last year. But when you get into more complicated math with vectors, they always talk about the vertical component or the horizontal. This is the horizontal component is always I, and the vertical component is always J. And then if you have if it's a three-dimensional vector, then the going back in and out with that would be the K vector, and you deal with all these matrices with vectors and all this kind of stuff, and it gets pretty tricky. But for now, we're just talking about two-dimensional vectors, and that's called the linear combination. So if I have a vector v where it's 3, -2, another equivalent way to write that vector is just 3i minus 2j. It means exactly the same thing, okay? And if the number in front of the vector, okay, if we call this a and b, then the magnitude of v, the magnitude of the vector, is going to be equal to the square root of a squared plus b squared. Just as kind of the same thing as we did with the component form of vector. Okay? So, and you do operations exactly the same way. So for instance, say we have let u equal 2I plus j, 2I plus j, and v equals negative 3I plus 2j, and they say find 2u minus v. Find 2u minus v. Well, that's just going to be 2 times 2I plus j minus negative 3I plus 2j. And then you would have to distribute this through, so you get 4I plus 2j minus, minus makes plus 3I minus 2j, which gives you 7I, which these things cancel out, right? Which means this is equivalent to a vector that is just going 7 units in this direction, right? This would be, if this is 1, 2, 3, 4, 5, 6, 7. Get that? Okay, so if I were to draw in this vector here, okay, it would look, the 2u minus v would look something like that. Now how would I represent that? Well, I would take a vector that is 2 times 2I plus j. So that would be 4I plus 2j. So if I went over 4 and up 2, right? You don't have to, but kind of graphically what it represents. If this is 2u, and v says go back 3 and up 2, right? But if negative v would be over 3 and down 2. See that? Okay, so this would be, it's not really drawn to scale, but if this is negative v, if I take 2u minus v, I would get this same result as getting a vector from there to there, which would be 7 units to the right. Yeah? Okay. Okay. Done. Not done. Sorry. Now we got to talk about. Now we have to talk about direction angles. Okay. You ready? You need a break yet? No. Good. Okay. I want to switch this thing. Direction angles. Sometimes the movie freaks out. Direction. Direction angles are the angle you can clockwise from the. So direction angles are the angle the vector makes counterclockwise. So it's just like you're in the unit circle with the positive x-axis. So, for instance, okay, and a general form. Well, first, let me kind of teach you with an example. So, say, for example, let's change this to blue. Okay, here I have an x and a y-axis, That's not a very good x and y axis, sorry. And then I have some vector, the orange vector, going this way. And say it has a magnitude of 6. Okay? Magnitude of 6. And this angle is 30 degrees. Right here. Okay? This vector can be expressed like this, as 6 times the cosine of 30 degrees in the I direction plus 6 times the sine of 30 degrees in the J direction. And where that comes from, you're just breaking this vector down into its horizontal and vertical components. Because if this is VI, or we'll call this V sub I, and this is V sub J or something like that. So do you understand that V sub I would be so adjacent over hypotenuse? So V sub I would, or the cosine of 30, you don't have to write this, I'm just trying to show you where it comes from. Cosine of 30 would be V sub I over 6, right? And so this is like the horizontal component right here, and this is the vertical component right there. So it's a way to break down, so when you have direction angles, you could write it where this is theta in here, okay? So the cosine of that angle times the magnitude is going to give you the horizontal component, okay? And the sine of that angle times the magnitude of that vector is going to give you the vertical component, okay? And that's very useful for when you're doing vector problems, like trying to find forces on things or directions that airplanes are going, or different tensions on cables and stuff like that, because maybe you have a cable pulling this way, and you want to know how many pounds are going this way and how many pounds are going this way, because you want to, we'll do some examples, you'll see. Okay, so that's the thing about direction angles, and I'll give you a couple examples. So if I did this, and they say change this, I guess you would call this direction angle form. I'm not exactly sure what form they call this, but if they say change this into component form, then you just take the cosine of 30 degrees, right? 6. Anyone remember what cosine of 30 degrees is? Please. Root of 3 over 2. Okay? Now 1/2, that's the other one. So it's 6 times the root of 3 over 2i plus 6 times the root of 3. What's the sine of 30 degrees? 1/2 in the J direction. So that simplifies to 3 root of 3i plus 3j. So in other words, if I have an angle here of 30 degrees, if I know this angle is 30 degrees, and I know the strength of this vector, or the length, if I draw a picture of it, is 6, then to get there, I could go 3 root of 3 over in this direction. Root of 3 is about 1.7, so 3 times that is about 5.2 something or something. So I go over 5.2 something, and up 3, I would get to that same point. See? Okay, and that's kind of a way you could break it down. Okay. If B equals A plus BI, next thing, if V equals AI plus BJ, then tangent of theta equals B over A. Okay, where theta is the direction angle. But you have to be careful. You can't just take the inverse tangent of b over a and find the direction angle, because sometimes you'll get an angle, like if it's negative, you'll either get an angle down here, right? Because tangent is negative in two places. It's negative down here, right? And it's negative up here, right? So if I just were to take the inverse tangent of b over a, I wouldn't necessarily find what the direction angle is. I would just come up with a number, and from that number, I would have to figure out which quadrant I'm in, and then figure out the direction angle. So I'll do an example of that in a minute. So for find the direction angle, this one's easy. For b equals 3I plus 3j, find the direction angle. Could you do that? So tangent of theta is equal to 3 over 3, which is equal to 1. So if I take the inverse tangent of 1, who remembers what that is in degrees? 45 degrees, okay? So in that case, the direction angle is the same as the inverse tangent, okay? Because that's just a vector where you're going over 3 and up 3. So if I went over 3 and up 3, that would give me this vector here, and this is theta equals 45 degrees, right? That's pretty easy, because the direction angle is the angle that the vector makes with the positive x-axis, okay? However, if I have something where I have negative values, okay? So let's change the name of the vector instead of using u all the time. For w equals 3i minus 4j. If I said find the direction angle, it's a little trickier than that, because so first of all, which quadrant am I in if I'm going over 3 and down 4? I'm in the fourth quadrant, right? So over 3 down 4 is going to put me somewhere over here. So if I go theta, so I know that the tangent of theta, which is the direction angle, is equal to negative 4 over 3. And I take the inverse tangent to figure out what that angle is of negative 4 over 3. I end up with an angle which is approximately negative 53.13. I did it. You could do that on your calculator, right? So for most of these, I think we'll be in degree mode, right, rather than radians. But that's not theta. That's this angle right here, right? The direction angle is the angle that the vector makes with the positive x-axis. Okay, so this is theta. So how would I find theta?
360.
Yeah, 360 minus that. So theta, the direction angle, is going to be 360 minus my 53.13, which gives you, don't tell me, 306 point something. 306 point, what's that, 47? 87? 87, thank you. 87. Okay. Okay? Questions? Grounds? Okay. So that's how you find direction angle. You got that? Do you wanna take a 2-minute sleepy time? Okay, I gotta pause my okay, so I'm recording here. Okay, so find the conic form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour, an angle of 30 degrees behind the horizontal, and the picture is shown. Okay, so basically what you want to do is if the plane is going this way 100 miles an hour and this is a 30-degree angle, right? You want to break it into its horizontal and its vertical component. And this is a really simple, straightforward problem, but you got to be a little careful. You're going to go that the vector is equal to the cosine of how much? It's not 30. You got to be careful, okay? You got to call it 210 because the direction angle is the angle that it makes, because that's going to count for the vector having that part of the vector being negative, right? So you want to call this a cosine of 210 degrees in, whoops, I forgot the magnitude. Magnitude is 100, okay? Cosine of 210 plus 100 times the sine of 210. Okay, so you have to call it the angle from the x-axis. You could also call it negative 150, but that gets kind of complicated anyway. Okay, so v equals 100. Anyone know what the cosine of 210 is? Negative or positive? Negative, and that's the same as the cosine of 30 degrees, which is what? We already did this one. Negative 3 over 2, negative root of 3 over 2. Okay? Whoops, I forgot my I component, and I forgot my J component over there. Okay? So in the I direction, plus 100, is sine negative or positive down here? Negative. Okay, and sine of 30 is, or 210, it's negative 1/2. Okay? In the J direction, and then I just simplify that to negative 50 root of 3 in the I direction minus 50 in the J direction. Okay? So in other words, if this plane is going 100 miles an hour this way, it's going 50 root 3 miles an hour in this way, which is, I don't know, 70 something. Okay? And it's going 50 in this direction. Get it? Easy? Easy? Yes, ma'am.
So what's the speed, the magnitude of the speed?
The speed, yeah, the speed is the vector direct, the velocity is direction, okay? But so speed is the absolute value of velocity, so the speed is the magnitude, okay? Good question. Okay, so that's the easy type of word problem, right? Okay, next type of word problem that you're going to see is here, okay? Oh, I didn't want to put the, they give you a picture. So this one is a little, I think it might be a little hard for you to see, but what is here, oh, let's see if I can use my cool geometry tools, okay? Let's get a right triangle going here. What is this? Oh, geometry, I want a right triangle. Well, let's see if this works. Let me just practice over here. Now, what if I went over here? Oh, yeah. So, I don't know if this will work, but I'm going to try. And not very good. Forget it. Okay. So, you have a force of 600 pounds is required to pull a boat up a trailer, up a ramp incline at 15 degrees from horizontal. Find the combined weight of the boat and the trailer. In other words, what they want to know is I could break this force going this way into a force going this way, right? And a perpendicular force to that going perpendicular to the ramp. Okay? And when I taught this last year, we did with projections of vectors, and it gets way, way, way too complicated. But what you have to know is that this triangle here, this triangle, okay? And if you remember from geometry is similar to this triangle here. Because if this angle is 15 degrees, what does this angle have to be right here? What's that angle? If this is a 90 degrees straight down. What's that got to be? No, that's complementary to that, right? 75. So that angle's got to be 75 degrees right there. And this angle is perpendicular to the ramp, right? So so this little angle right here has to be what? That little angle right there has to be what? 15 as well, right? Because this angle 75 plus this little one has to add up to 90, right? So therefore, this angle here is 15 degrees, and since this is since I want a force going in the same direction as the boat, and one going perpendicular, I could break this force into one going. Well, this is the force going. This is this force, right here. But I could break that force into one going this way and one going this way, which is what you want. You want this thing right here. Okay. So basically, what I'm doing is I'm looking at a right triangle. Okay, where this angle, I could use my tool on here, where this is 15 degrees. This is, right here, is 600 pounds. Okay? And don't worry about the signs of things, because in actuality, right, you're pulling if I'm pulling up the hill, I'm pulling the boat up, and if I'm pulling up the hill, I'm pulling the boat up, and I'm pulling it horizontally as well. See that? But I'm breaking it into two other forces. So this is 600. How could I find this force right here? We'll call it for Fg, for the force due to gravity. How could I figure that out? Easy trick. What side is this? Opposite. What side is this? Hypotenuse, right? So I have the sine of 15 degrees equals 600 over F sub g. That's the force going due to gravity. And if I do that, I can switch places with these two things, and I get the force due to gravity is equal to 600 over the sine of 15 degrees. You know that algebraically I'm allowed to do that. I'm cross multiplying and cross dividing or something like that. And then if I do that, I get that this is about, how many pounds? 625. No, that's the wrong problem. I get that force is about 2,318 pounds. So, how do you write pounds? LBs, or sometimes they use the numbers. So that's kind of interesting. You'd say, well, I know this thing, it's kind of cool because if you're doing a problem, and I say I'm pulling this up with 15 pounds of force, and my angle of my ramp is 15 degrees, how much does that boat and the trailer weigh? So you could actually break it apart. Or you could, using cosine, I believe, you could figure out this force, right, which would tell you how much force is pushing on that ramp, which might say, okay, can my ramp withstand this amount of pressure? Because it doesn't need to, I don't think it needs to withstand 2,318 pounds. It needs to withstand the perpendicular pressure, I think. So, in any case, that's how you do that. Did you get that? Easy? Okay, then we have one more, and then we're done. Okay? One more, and then you're going to run into one that, but I'll let you work for a while before you do that. So, the next type of problem I stole out of another resource, okay? And it looks like this. You guys know what bearing means? I couldn't find the degree symbol on there, so there should be degrees. This is a bearing problem, and when you do vectors, they like to talk about bearing problems. My skateboard had a bearing problem the other day. You get it? Bearing. Okay, anyway. Okay, a plane has set a bearing of set. So what you want to do for this type of picture, for this type of problem, sorry, is not do that. You want to draw arrows with lines on both ends. Okay, so let's just draw this. So what you want to do with this type of problem is draw a picture. Okay, so a plane has set a bearing of south 60 degrees east. What does that mean? What does south 60 degrees east mean? Did you do this last semester? You did this last semester. It means good. It means 60 degrees from south. East, it means what it says. So if this is south, then I go 60 degrees to the east of south. So this angle here is 60 degrees. Okay, so that's where it sets its bearing. All right. The wind is blowing in the direction north, and the length of that vector kind of represents the speed that plane is trying to go. Okay. And then the wind, however, is blowing north at 45 degrees east at 80 miles an hour. So I could draw that vector up here, okay, where this angle is 45, is that right? North 45 degrees means that this angle here is 45, right? Which also makes this angle 45, yes? But really, that's not where the resultant is going to be. I mean, I could add these two vectors, but the wind is blowing this way, the plane's trying to go this way, right? So really what's happening is I add vectors, I want to add these two vectors together. So in other words, if I were to draw in a little, let's get the arrows on here, and draw in a little XY axis right here. So let's see if I can do that. Trying, okay. This angle here is right here. No, both of these would be 45 degrees. So this one right here is 45 degrees. Yes? What I'm looking for is the magnitude and direction of this vector going from, why did it go that way? I don't want it to. We go this way. I don't want it to be dotted, be solid. Let's make it green. Okay, so if I start here and go to here, that's what so my airplane's going to end up doing something like that, right? And they want you to figure out like how fast is it going and what direction is it going, all right? And some people do this using log cosines, and it can be done very easily using log cosines, but I'm not going to let you do that on a test. So if you do it in your homework that way, it's okay, but we really want you to get the idea of adding together vectors using their component form and stuff like that. Okay? So what you're going to do is you're going to add together, so P equals speed of plane. Speed of plane, okay? Or not speed of plane. P equals we'll just call it the plane vector. Not the speed. P equals the plane vector. And we'll let W equal the wind vector. And then I want the result, what would we call it, actual or something like that? The actual vector, or the resultant vector, is just going to be P plus W. Would you agree with me there? Okay? So P equals, he's trying to go 600 cosine of this angle from here to here, not from there to there. Oh, now I'm going to try to erase. Oh, I'll just go back. I was wrong. Okay. 600. I want to know this angle from there to there. What's that angle? it's 330 degrees, right? You guys understand why that's 330? Because this is 60, so that'd have to be 30, so you're 30 short of getting back to the x-axis in the I direction. Plus 600 sine of 330 degrees in the j direction. So that's my p vector. And my w vector is going to look like 80, right? 80 cosine. And this it's just 45, right? Because it's going out from the x-axis. So it's 80 cosine 45 in the I direction plus 80 sine 45 in the j direction. Okay? Now this is a pain in the neck. I'm going to simplify these. So P is equal to 600 cosine of 330. There's that root of 3 over 2 again. It's positive. 600 times the root of 3 over 2 in the I direction plus 600 sine of 330. In this case, it's going to be negative, right? Negative 1/2. Understand that? Okay? And I'm going to simplify this some more to be 300 root of 3 I minus 300 j. So that's a simplified form of the plane vector, which direction it's trying to go. The wind is going to simplify. What's the cosine of 45? Root of 2 over 2. So root of 2 over 2 I plus 80 sine of 45 is also root of 2 over 2. Root of 2 over 2 j, which gives you 40 root of 2 I plus 40 root of 2 j. Alright? And you want P plus W. So P plus W is going to be, I'm going to move because I'm very twisting me backwards. I can write from back here. P plus W is going to be 600, no, wrong, 300 root of 3, 300 root of 3 plus 40 root of 2 in the I direction, as I'm adding together my horizontal components, right? And I'm going to add together my vertical components, which is minus 300 plus 40 root of 2 in the j direction. Okay? And unfortunately, I'm not done with the problem yet, okay? Because I want to find the magnitude, because that's going to tell me how fast the plane is going, right? The magnitude of P plus W is going to be equal to, and you plug this ugly thing into your calculator. You have to go like this. And 300 root of 3 plus 40 root of 2 quantity squared plus negative 300 plus 40 root of 2 also quantity squared. And if you do that on your calculator, you should get approximately 625 625.33, and that'd be in miles per hour, which kind of makes sense, right? Think of if your answer makes sense. If he's trying to go this way and the wind is kind of pushing him in the northwest direction, is he going to be going faster or slower? A little bit faster, right? If the wind was going this way, it'd probably be going a little bit slower, right? So he's going to be going a little bit faster. Now to find the direction, okay? To find the direction, hey, go away. To find the direction, we have to find the tangent. We have to know that the tangent of theta is equal to the y part over the x part, okay? So you're going to go negative 300 plus 40 root of 2 divided by 300 root of 3 plus 40 root of 2. And then if I take the inverse tangent of that mess there, which I'm not going to write again, you get about, that's about negative 22.9 degrees. 22.9 degrees. So when you talk about direction, that's really not a good way to talk about it. You want to talk about it either in terms of a bearing or degrees from, or you can talk about the direction angle. I would just talk about it if this angle to, so what I just found is that this here is negative 22.9, right? So that the bearing, okay, which has to be expressed from either north or south, okay? So the bearing is going to be south. What's that? South, we have to go 90 minus 22.9, which is 60, 67.1, is that right? Who's a smart kid? 67.1, is that correct? Yes, 67.1 degrees. So it'd be south, 67.1 degrees east. And now you found the magnitude direction. Okay? Now you could do that with a lot of cosines and a lot of sines and stuff like that. But we really, Mr. Beamer said a kid did it that way. But I really want you to do it with vectors and all that kind of stuff, because it's important that you're learning that method and breaking it down into its components and all that stuff. Okay. And that's the end. And your homework is 1 through 1,000 all. No, I'm just kidding. It's on my website. And the first ones will go, there's only like 3 hard word problems. Not hard. The first 2 are easy, actually. 429, 49 through 89, every third. So that's about 15 problems, I think, or something. But those are quickies, okay? And then 3-word problems, 97, 98, and 105. Okay? And now I could turn off my recorder if I could find it. Where's my recorder? Hello. Where?
You minimized it.
Where did it go? Oh, there it is. I could stop.